So, a while ago when Civo folks asked me, hey, would you like to come and talk at Civo Navigate? I said, yeah, I like Civo folks, right? And then they asked me, hey, what would you like to present? And I said, hey, how about this? I can build a full internal developer platform in half an hour. It's most likely going to fail. It's too short of a time, but in half an hour I can build it, and I would need 15 minutes to explain first what I'm doing, right? So 45 minutes. Most likely it's not going to work, it's going to fail, but I'll try. And then yesterday when I was checking the schedule, I realized that actually it's 25 minutes in total. So what you're going to get today is something that is almost certainly not going to work, and I will have to talk at triple speed. So you've been warned, nobody's going to understand what's going on, but we'll try, right? So in the spirit of I don't have time, I'm going to skip introducing myself. I'm Viktor, I work on Upbound, I have Twitter account and all this stuff, right? So let's start with what do I want to accomplish, right? And I think that the goal of majority of us is really to make the situation in our company in a way that everybody can be autonomous, right? Everybody of us, each one of us should be able to do whatever we need to do without involving 57 other people, right? Without opening 75,000 Jira tickets to get something done, right? And that means two things, right? You're an expert in something, and I have zero doubt that you're capable of doing whatever you're expert in, right? You might be Node.js developer, you might be sysadmin, DBA, whatever you are, right? But then there are some other tasks that you don't know. You're not an expert. You didn't spend 17 years learning Kubernetes or 57 years being DBA or whatever you are, but you still should be autonomous, right? And that's the whole idea of internal developer platforms. How can I be an expert in something and then codify that expertise so that I can offer that expertise as a service that others can consume, right? And that can be anything. That can be database, that can be a cluster, that can be how we build applications, that can be how we deal with security, anything, right? So if you want one takeaway, that's that IDP is an attempt to codify somebody's experience and plug it into a platform so that others can consume that something as a service instead of opening Jira tickets. Okay? Jira tickets need to die. That's the second takeaway from this talk, right? So, internal developer platform. So what I'm going to do today is do a very, very quick demo of one possible out of thousands of ways how we can do it. So, and the goal of the demo, the one that I will have to do in 7 minutes instead of half an hour, is for somebody to click a button, to fill in few fields in some easy to digest interface, wait for a few moments, and a new, in this case, example, a new backend application will be automatically added to that interface. You will see it. Okay, so this is what you created. A new repository will be created for the code of that application. A container image will be built with the first release of that application and pushed to registry, of course. We will update manifests in a repository dedicated for, let's say, production or some environment, right? What you call GitOps, Argo CD, Flux, whatever you might be using. The first release will be deployed today using Argo CD. A database will be created because you need to store the state somewhere. So backend application with a database that will be created somewhere. And from there on, from that moment on, right, that same person who or a team that created all that, right, with the button, will continue working by writing code of that application and pushing that code to Git, right? That will be the only action afterwards, right? I'm excluding now from today's story observability, how that some team would observe the state of that application. I mean, you can observe it with in some ways, but not really seriously. So I'm skipping maybe the last part, but hey, I have 7 minutes. So new releases deployed auto-magically, which is what we already want. Right, now the architecture, so now imagine that we are starting from scratch. Now, almost nobody starts from scratch. You will never design something like what I'm showing here because everybody has a baggage, right? We all have some things that we've done in the past and they follow maybe different logic, but if we would start from scratch, most likely everybody would build something similar conceptually, I'm not talking about using the same tools as this. And first thing you need to think about is control plane, meaning that, and control plane can be anything, right? What is that entity, that server or a cluster or something that is orchestrating everything that we do, right? And that everything that we do can be many different things. Can be, hey, that control plane will do something in Kubernetes clusters so that your application is running there, right? That control plane can do something else somewhere else, whatever you're doing, right? The job of a control plane is to manage and orchestrate stuff across your system, right? Can be AWS, Google, Azure, whatever that is. Now, on top of that, if we want to simplify things for people, we need to create the right level of abstraction. That means that, hey, I'm a Kubernetes expert. For me, the most logical way to define an application is to write 70,000 lines of YAML that will contain a deployment ingress service, virtual service, and 57 other things that nobody ever heard of, right? But for everybody else, if that's not your level, if that's not your expertise, and you would like to do it, I need to create an interface that will be at the right level of abstraction for you, right? And what is the right level of abstraction depends, right? It will differ from one team to another, right? Depends. Somebody says, hey, the only thing I know how to do is to say I have an application, right? Some other people will say, hey, I want to control the number of replicas, right? Or I want to specify this or that. Anyways, we need to create those interfaces that people will be able to consume. And interfaces today are always APIs, right? Now, please don't tell me that interface is CVS file or JSON or something like that. That's not an interface. Interface is an API. We need Git, of course, unless anybody using SVN? No? Okay, cool. We advanced. We will need somehow databases, right? Databases are useless by themselves. We need to figure out how we're going to manage schema of those databases. And we need to manage secrets because Git is great for almost everything. Not literally everything. Some things don't go to Git. If that's not your case, please let me know what's your Git repo. Some graphical user interface. Now, when I say graphical user interface, that could be web UI, but Visual Studio Code is a graphical user interface. I mean, heck, Terminal is also graphical. I can draw some things over there, right? So some kind of interface through which people will interact either through those interfaces like APIs, right? So graphical user interface either goes to API or Git. Now, in my case, I prefer that nothing goes to API directly, right? That interface should be reading from the API. Hey, give me the list of all the applications. What are the databases you have, right? Read-only mode and write to Git only, so that I always have a record of what you wanted to do, right? And we can collaborate, we can create pull requests, we can spend time on, we can use daily stand-ups to review the pull requests, whatever you're doing to waste your time. We will need pipelines, right? Because there are two types of activities we do. One is what I would call one-shot actions, right? Those are the things you do once and only once and never again, right? You build an image only one time, right? For a commit. You will never say, hey, why don't I build this image 5 times for this commit? That's silly, right? And we'll do those things with pipelines. I'm intentionally calling them pipelines, not to confuse with people called it CI/CD, which is a separate discussion whether that's CI/CD. Anyways, pipelines that will execute some actions, and we will have those actions will be either pushing images to some registry, I mean, running tests and things that you normally do, but among other things, we will push some images to a registry, and we will push some changes to a Git repository that will initiate synchronization with my system through the control plane, right? How much time I spent so far? 9 minutes, okay. 15 minutes for a demo. And then we have a people. My mission is to eliminate people. That's the thing I like the least. But so far, we need to deal with them. So those are the things I will try to do right now. Demo. I don't like slides. I don't like talking too much. I like showing things. So assuming that this works, you can hear me. OK, so let's go into it, right? I'm going to skip the setup. What I did in advance is I executed a script here. Slides are online. If you want to reproduce what I'm doing, you can do it easily. You run a script, you get the full setup, or you're a security person and you don't run a script and you read the script and evaluate everything that Viktor did not do, anything that should hijack your cluster, whatever I might be doing, right? So the first thing, first thing, control plane. We need to figure out how we're going to manage stuff. I'm going to use Crossplane because that's the project I'm familiar with, right? I'm not saying you have to use Crossplane. You can use many, many other things, right? But I will use Crossplane, and the idea will be, actually, the best candidate for a control plane today, right now, is Kubernetes, right? Because it has many of the qualities that are already available. Do I have an API through Kubernetes? Yeah. Can I extend it to be exactly what I want? Yes. Does it do drift detection, reconciliation, all the other stuff? Yes, right? So I'm going to use Kubernetes as a control plane that will manage everything. So this is a bit different from what you might be used to. Many of us are thinking, hey, Kubernetes is a thingy that is designed to run containers. That's bollocks. That's not true at all, right? Kubernetes is, first and foremost, extensible API that has controllers that do something depending on what you tell the API you want. And that something can be to run containers, but can be many, many other things. And I will use Crossplane to extend Kubernetes to manage stuff, whatever that stuff is. Now, to give you an idea how that looks like, I already have, I installed Crossplane, and I installed some couple of providers, and I got custom resource definitions. Is this big enough? Do you see it? OK, cool. So I installed some custom resource definitions that extended my cluster to do additional things. And additional things is many. Kind of, I don't know, I can, what is it? I can create RDS, I can manage RDS clusters in AWS, right? And so on and so forth. So Crossplane gives you capability to providers to extend the interfaces that you can use in Kubernetes to manage stuff, whatever the stuff is. In this case, Google Cloud, Azure, and in my case today, I extended it to use with AWS, Google Cloud, and Azure. And so cool. I have a control plane. It can manage stuff, right? Now, the next thing I need to figure out is user-friendly interfaces. Now, this is the last time I will mention Crossplane, I promise. Other tools are coming. Because Crossplane has two important features, right? You have providers that give you custom resources in Kubernetes, custom resource definitions in Kubernetes that allow you to do stuff like, oh, I want to manage EC2 instances in AWS, or whatever that something is. The other important thing is what we call compositions. Now, compositions allow you to create your own custom resource definitions that will create certain level of abstraction, certain new interface that will do stuff, whatever the stuff is. You will see what the stuff is. So here I created kubectl get here this. This is made for short people. This is horrible. Grep DevOps something, right? So I created a couple of my own. This does not come out of. I created my own extensions of Kubernetes to have something called SQLs or SQL claims that will allow people to manage databases using through interface that allows them to specify what they need and ignore the things that they don't, right? Because nobody nobody except people who spent 17 years in AWS know about subnets and VPCs and internet gateways. Nobody cares about that. I want a database, and then you say, yeah, where do you want it? In AWS, yes. 57 different things you need to create, and you get easy way to create, insane. Anyways, so what I'm going to do is, actually, let me first show you kubectl explain up claims. No, let me copy it. Here we go, right? And recursive, right? So you can see that's the beauty of Kubernetes. It's API. You can discover what something is, and you can see here that I created a specification that allows people to put some parameters, and parameter says, hey, what's the size of the database and what is the version of the database and a few other things, right? Easy. Now, how that looks like, crossplane, I have YAML. I have this file prepared. Oh, this is terribly wrong. Sorry. I just realized that I set up everything for GCP and realized that actually I'm using backend DB Google, let's say. I think it will probably not work, I already promised. There we go. So, that new interface for that developer who wants to manage a database, I specified through that .crd that you can create your own manifest, and they're easy. Two things you need to do. First, define through labels what do you want. You can have a list of things that you can do, like in this case, hey, I want a backend application that has a database, and that database should be running in Google. And it should be running, the application should run locally, meaning in the same cluster where I have crossplane, because I'm too cheap, I didn't want to create a real cluster for you guys. And then there are a couple of parameters that people can specify, right? There is no way to specify subnet because nobody cares, but they can specify the namespace. Hey, I want to do it in development environment. This is the image of my application. That's the port of my application. That's the host. And the database is going to be version 14, Postgres in this case. And it will be medium size. Easy. Medium size meaning that I don't know, I have no idea what's medium size in Google. Probably it's, I don't know, T2 something, right? Anyways, so I figured out how to create interfaces that will be useful for others who want to manage applications, in this case in databases, through Kubernetes. Now, what I could do now is do kubectl apply, and that would create a application, a database, and everything. I'm not going to do that because that's just silly. Nobody should ever do that. So we're going to go to the next section. Now I need to figure out how I'm going to synchronize what I want with what something is, right? And what that means really is that what I want is what is stored in Git. What something is can be anything. In this case, it will be database in Google Cloud and application running in some Kubernetes cluster. And all that is going to go from Git to the control plane. Control plane will figure out, oh, this goes here, this goes there, manage stuff, right? I'm going to use Argo today. I already installed Argo, and here is Argo, right? Right now it's empty. I have this application production infrastructure, nothing inside. I'm not cheating here. It's not a video either, this is live. And production apps. So I created two Argo CD applications that just monitor two different directories in a Git repository. They're empty right now. What does matter is that I figured out how I'm going to synchronize things. I'm going to use Argo CD. The next thing I need to figure out is how I'm going to manage schema of my databases, right? Because I can create a database. I didn't show it to you yet, but you saw that I can create databases wherever I want through compositions, crossplane. Now I need to figure out schema management. Now, schema management is the trickiest part because if we are going to use Kubernetes as a mechanism to do stuff, we need to define schema somehow in Kubernetes. There are only two tools I know of. One is Schema Hero, which is the one I'm going to use. There is another one called Atlas, which I'm not going to use today, mostly because I did not rewrite the demo. So I'm going to use Schema Hero. And the way I'm going to do that is from now on, I'm not interacting, I'm not touching my control plane, I'm not touching my clusters. That's gone. That's not happening anymore. The only thing I'm allowed to do is either click buttons, I did not get to buttons yet, or I can I can push things to Git. So I can do something like this. I can copy this file. This file is nothing special. It's just Argo CD application that says, hey, that's the repository, that's the path, the directory. You will find it there. That's where the manifests are of Schema Hero, right? So git add, git commit, message is something, and git push. There we go. All right, that's it. That's what I need to do to install stuff, in this case, Schema Hero. Eventually, Argo CD will figure it out, and things will happen, right? I don't need to worry about that. What does matter is that I checked off one more thing. I know how to manage schema. You will see it in action at the very end. Or not. Probably I will not have time to get to the end. Anyways, going on. Secrets management, you need to figure out where I'm going to keep secrets, like where is going to be the authentication for the database, right? Password. Either in Git or in Google Secret Manager, right? Now, I'm going to use external secrets operator, which basically essentially allows you to synchronize secrets from wherever into your Kubernetes cluster so that you can read it as a secret and do something with it, right? And to do that, I'm going to copy and paste because I don't have time to type. And what I just did is very simple, right? I have this YAML, another Argo CD says, hey, in this case, that's the repository of a Helm chart for external secrets, couple of values over there, go, right? I'm going to push this file to Git, and that's it. Git commit -m something and push. No, git push. Git push. There we go. Now, there is one more thing I need to do, and that's copy one more file. Let me see first, is Argo CD even working? Yes, it is. You can see that here, no, that's production apps, production infrastructure. You can see that external secrets and Schema Hero are already up and running or will be running soon. Now I need one more thing, and that's secret store Google, which I'm going to copy to infra directory again. I'm going to show you what that is. Commit -m push. Now the second thing I need is this that essentially says, hey, for you to communicate with my Google account, these are the credentials that you need to use in Google, right? It will differ from one provider to another. Nothing really special. Okay, so I figured out, where are my slides? I figured out how to manage secrets. I mean, I figured out. It takes a bit more than 5 minutes, but eventually you manage secrets, and there are two things missing. One of those two things is how are we going to present all this to people, right? Some people like writing YAML, that's great. I'm one of those. I don't like anything that has more than 2 colors, black and white terminal, that's me. But for the majority of people, probably you need something with pretty colors. You need to have a bit of green and a bit of red and a bit of blue, right? And if you're a vendor, then that's a must because people buy your stuff only if it's colorful, right? Nobody uses that afterwards, but that's what sells. So I'm going to use Port today. Port is a project, if you're familiar with Backstage, think of Backstage without spending 17 years trying to figure it out. That's the major difference. As a builder, it's easy to figure out as end user Backstage, but creating, what I'm going to do is I'm going to open this. I'm going to open Port. There we go. Maybe. Yes. It will eventually work. I already have something. There is something called blueprints, which you tell port. Port starts with a blank slate, right? And there is a blueprint that you tell, hey, what is the things that you want to catalog, to present to people? And I created some things for Kubernetes. We're not going to use that today. What we are going to use is this, a couple of things. First, environment. This is a blueprint that says, hey, you have something called environments. You can have production, staging, whatever, right? You're defining what things are, and I'm going to use this and copy it, and I'm going to go to port, and I'm going to edit and say, no, not a template. Templates are evil. Custom blueprint, edit JSON, There we go. And we have something called, you don't see it probably here well, but here is I did environment, right? Kind of people need to know whether it's production or something else. And I'm going to add a blueprint for backend applications, which is, no, what did they do? There we go. Basically, what I'm saying here is, hey, whenever somebody wants to work with something called backend application, you have something called URL for the address where the repository of that application, language, with a list of all languages that are acceptable. There we go. And the host and stuff like that, right? You define what is the interface. I'm finished. I'm sorry. I couldn't make it. Eventually, it would create GitHub Actions that would create the repositories, and it would push things to Git, and then you would live happily ever after.